Hello everybody out there in YouTube land. This is Good Times for All, or Zachary Zabala here if you prefer. In this video, I'll be showing you how non-conductive materials can also become polarized, where they have a negative and a positive. How I'm going to be doing that is with electrostatic rods. What it is, I have a piece of acrylic here and some silk. And then I have a piece of amber and some fur. Now what it does is when you rub these together, it creates an electrostatic charge. The acrylic is going to gather the positive charge, and the silk will gather the negative charge. On the opposite end, your amber rod will collect a negative charge, while the fur will collect the positive charge. It's conservation of energy. You cannot create or destroy it. So when you make a positive charge, you automatically will make a negative charge to go with it. So it can pretty much, it cancels itself out. So for every positive charge out there, there was a negative charge created as well. So we're going to start, well, this balloon is already polarized. I've been playing with it a lot. I've learned that for some reason, these balloons, I don't know if all balloons do it, but it's not very hard to polarize a balloon. I think I already did this one on accident. I can get it to draw towards me. So it's not really, this is a positive, so the balloon is more negative charged than it is positive. And then when I bring out the amber rod, the negative charge, it'll push it away from you. From me. See that? Now I'll take the negative to this balloon. Now as you'll see, this balloon isn't really going to push away too far, but it will, it'll turn to have the negative side facing me. So with you seeing the clear side of the balloon, it is their this is the positive side, actually, of the balloon, coming towards the negative rod. Then we would take a positive rod. The balloon's already starting to turn, isn't that crazy? And I'll put it here, and the balloon will line up the other way, because this is a negative. Now as you see, when I do it to this balloon, it really wants to come towards me. This balloon is more polarized. So when I put this here, oh, let me charge it up a little bit. When I put this here, did I touch it? There we go. Maybe my hand was getting in the way. It will still, see how it kind of pushes it away, even though it is attracted over here? I'll show you what that is. There's a reason why this one automatically comes towards it, and this balloon does not. It'll just line up with it. Starting to lose its polarity, it looks like. Bring out the negative. And there it is, lining right back up. Bring out the positive. And there it is. I kind of had to help it around there a little bit. And we're going to learn why that is. I'm going to get out the whiteboard here. And we're going to see what's happening. So you have your balloon that is hanging here by a string. And we have our rod. Okay? We're going to be using the amber rod. The amber rod will become negatively charged, like I showed you. What this does to the balloon, it will then create a positive, all the protons, as people like to call them, which is a theoretical object. gets attracted to the rod. So it'll gather up on this side of the balloon. And all the electrons, another theoretical object, is being repelled away from the negative. And it will end up over on this side of the balloon. Therefore polarizing the balloon, making this side positive and this side negative. And a lot of objects this can happen to. Now, I don't know how long they hold their polarity, but a magnet is a polarized object. Kind of the same concept. You take a very large quantity of electricity and run it through certain types of metal at very, very, high voltage, and that's how they create magnets. It does this, but almost permanently. There are ways to get rid of a polarization. You add heat, and things will become polarized again, or non-polarized in a magnet. So that's it, folks. That's how it happens, though. That's how at least they explain it. The protons and the electrons, how they act. I don't know how true all that is. Like I said, they are theoretical objects, but that's how they explain it as of right now. So that's it. No, it's not really charged. It's got a little bit of charge in it. I'll charge this up real quick. See if I can't. No. Well, it's got some charge. It'll bring it a little bit towards you. But that's it, folks. Static electricity and how it can polarize non-conductive surfaces and objects. So this is Good Times for All signing out. As always, thanks for watching.